Hey everyone, welcome back. So today we're going to talk about role-based access control. Now, before talking about RBAC, or as it's called role-based access control, let's see what a specific role is. Now, role in the context of Azure, it's a combination of multiple permissions which are defined for each resource. Now, for example, when you go to a resource, you are now able to see this information. For example, the vault URI, what is the directory ID, and other information. And probably you can also go and create a new key. So these are all the privileges that were assigned to me, and this combination of all these privileges or permissions is defined as a role. Now, where you would find these roles, which are already defined, is inside every resource. You can go to role into the access control and then roles, and then you will see each and every type of roles. Now, please note that this will be different for each and every type of different type of resource. So, for example, Key Vault might have something called Key Vault Crypto User or Key Vault Secrets Reader. And storage account might have something different where it is something related to storage reader or storage contributor, etc., etc. There are, however, default roles which are, owner, contributor, reader, and user access administrator, and log reader, and monitoring reader, and stuff like that. Now, the important roles or privileged roles are what you see over here, which is owner, contributor, and user access administrator, which is common for everything else. Now, there are also other users which are, the role RBAC administrator, role-based access control administrator. And with respect to each and every resource type, it might differ. So, for example, for a key vault secrets reader probably is a very, very important thing because that user or that identity basically can read any secret that is present in this particular key vault. Now, let's revisit this specific part in a while. But back to the basics. Role, as I've mentioned earlier, is a combination of permissions, and they are different for each resource type. Now, these roles can be assigned to either a user, to a group, or a service principal. Now, it can either be a managed identity or it can be an enterprise application or app registration. Now, we will talk about what service principal and managed identity is in subsequent videos, or I might just swap the video at a earlier in the earlier order. But it is important for us to understand what each identity can do. For example, if you go to a resource and you can click on check access, when you click on check access, you can enter the service principal or the user information. Okay, let me click again, or probably let me just do a refresh. Okay, yeah, sorry for that. So when you click on check access, you can just go and enter that username, which is, say, in this case, it can be Subhash. So let me just start entering the name, and if you click on it, you will see that this user has no roles assigned to it. Now, when you go and check another user who is, okay, I need to go back again, and I check this user, you can see this user is an owner and it is inherited due to my, role of uh, being an owner of this particular management group. Now, we'll talk about inheritance in just a moment, but this is how you can check access of any specific identity, be it any user, group, or service principal, or managed identity, using this particular option called check access. If you want to check the access of the current logged in user, you can use this view access or view my access button. Now, let's quickly take an example and try and understand this in a very easy way. Now, let us just assume that you have a website, right? Or you've created a website, or your organization basically created a website. Now, in this case, you're tasked to create an RBAC, or you're tasked to create a secure ecosystem for the entire thing. Now, let us just assume that uh, in your organization, there are 5 people. One is a developer who is responsible for project one, and you have developer two who is responsible for project two or who's working on project two, and then you have IT support who is responsible for creating users and a couple of other things, and then you have a security analyst who is responsible for identifying threats in the network. Now, typically, what is the role or what is the business of this particular developer one? This developer is supposed to look after any resources or anything which is related to project one. The same thing with developer two, he or she is going to look after P2 or project two. The IT support folks are going to look at the user access, how to provision new accounts on Azure and how to configure DNS and stuff like that. And security analyst is supposed to look at the security events and other related things. Now, what role-based access control is all about is you give access to a specific user to the maximum extent of what is required. For example, let us assume that whatever architecture we are seeing is for project one. This is a production website called p1.com, or p1.local. Now, this particular developer who's a developer who's dealing with P1 will have access to the backend server, will have access to the database, and this user will also have access to the logs, because this user is basically required to do all these things, like to basically monitor the database, to monitor the backend services, to deploy new websites, and to also monitor logs to ensure that this particular user has basically everything, like every component of his project or her project to be up and running. Now, the same way, developer 2 need not have access to the entire ecosystem. Maybe developer 2 doesn't need access to any of it, probably, but there could also be an instance where there is a managed identity which is related to P2, and it needs to access certain data which is related to project 1. Now, in that case, what P2 will have access to is this, which is database. Now, P2 is what this rainbow colored database, the permissions which are rainbow arrowed are assigned to managed identity related to P2. In this case, the developer of P2 is not required to be added to any of these resources in P1. And when it comes to IT support, the IT support guy will only require access to two things. One is Azure DNS, because they have to configure the DNS which is related to their websites or any other ecosystem, and Azure Active Directory. So it might differ based on the role. Maybe the Azure DNS is also required by the developer, but in typical case, let's say IT is sort of like asked to configure this website and stuff like that. Now, in this case, the Azure Active Directory where the users are created, and they will be given a very specific role called User Access Administrator or RBAC Administrator. So the IT support guy, he or she doesn't have to look at any of this information. For example, they should not be able to log in into this virtual machine. They should not be able to reset the password for this virtual machine. They should not be able to look at Azure Key Vault, and they should not be able to look at the data inside the databases. And the same thing, they don't have to look at the log data. So all they have to do is, if there is a new developer tomorrow, this developer or developer 3 who is going to work on P1 will approach the IT support, and the IT support will just add a role or to developer P1 or developer 3 or P1. This is how a specific fine-grained permission called user access administrator or RBAC administrator, which is a default Azure role, is used. Now, now in this case, what a security analyst requires is security analyst only has a requirement to access the logs, because the security analyst doesn't have to look at anything else. In this case, the security analyst is going to look at the logs, do some hunting on it, or do some investigation on it if need arises, and that is where the boundary ends. The security analyst doesn't need access to anything else. So in this case, the security analyst is only given access to this particular resource. Now, one question might arise to everyone is, hey, we're talking about access to this particular resource and access to this particular resource. Now, wouldn't it be nice if we had some levels of access as well? Now, this is where it gets interesting, right? Azure, as I've mentioned earlier, has, specific levels of access as well, which is like read, update, delete and modify. Sorry, update is already modified, so it will be read, update, delete, and other information. So basic CRUD operations. Now, the role, as I've mentioned, is just a combination of these specific permissions. Now, for an owner role, this owner will have access to read, update, and delete. So basically, the owner can do anything on that particular resource. However, the reader can only read that particular information or anything, any metadata properties which is related to that. Now, contributor may just have access to read, it is read and update, but not delete, or maybe in some cases he might also have access to delete. So for example, this particular role is already defined by Azure, and all the IT support guy has to do is just use this particular tag to assign it to developer 3. And for example, there are 100 more developers who are joining P1. The IT support guy can just use this tag to assign it to all the developers in a single shot. They don't have to recreate all the permissions. For example, if the IT support guy decided that, hey, I've got a fine-grained user permissions, they can create a new role and can assign it to all the developers at once, which will kind of be very easy when compared to adding each and every permission. Now, if you are interested to understand what a typical permission looks like, you can go inside this and you can click on view, and inside this there are permissions and in the JSON format if you're interested. So here, if you see, there are multiple namespaces. So this is related to AAD, this is related to add-ons, and this is related to the hybrid health service, and this is related to analysis service and other stuff. So this reader, any user or any identity which is added as a reader, will be able to perform all these actions. And the same thing is present in a JSON format in this particular tab called JSON. Now, if you would want to replicate it and probably create a fine-grained principle, you would just click on clone, and you can see the JSON. You can update the JSON part, and you can create, a fine-grained access control, which is what anyone would recommend for an enterprise which is mature. Now, moving on to how basically Azure evaluates, any role-based access control. And just a heads up that all these images are, any 90% of the images that are taken in the course are courtesy of Microsoft's documentation, and thanks to the wonderful people who are writing these documentation. So if I don't mention anything, it just means that uh, you know I've taken it from Microsoft's documentation, and I'll try to link those documentation links in the description for your convenience as well. Now, this is how typically Microsoft's Azure platform decides if a user is supposed to get access or not. First, the user. So when you try to access, let's say your user A, and you're trying to access Key Vault, which is key V1. Now, what the system is going to do is it is going to first assume that you don't have any access. Then it is going to retrieve all the assignments which are for user A. and then it is going to check what are all the deny assignments. Now, if you're wondering what a deny assignment is, there are two types of assignments, or basically assignment is, assigning a role to a specific identity. Now, allow assignment is basically, it means just allow the particular user, and deny is something that you can say, hey, don't allow this specific set of specific set of users, or do not allow this particular user to do this particular action. So one very important thing that we need to understand is any deny assignment which is present takes precedence. So if there is explicit deny, then the access is blocked absolutely. For example, if you're requested to do a read of any secret inside Azure Key Vault key v1, and if there is a deny assignment for you, but to not to read anything on key v1, then you won't be able to do it. Now, if there is no explicit deny, then the role assignments will be evaluated. And if there is a request match, so for example, if there is a specific inside role assignment, there is that, this can do a read of secrets in on specific key vault 1, key v1, then if there are any conditions, there can be other conditions as well, and if those conditions are met, the access is allowed, and if the condition is not met, the access is not allowed. So it's a very typical flow of how Azure RBAC is evaluated. Now, one more interesting concept in the way Azure RBAC permissions are assigned is hierarchy. So for example, if you are a user, if you have given access to management group as owner, then you will become an owner of these two subscriptions, and you will become an owner of these three resource groups, and you'll also become an owner of all these resources. Now, why this is interesting? It is because anyone who is given access to at a higher level than what they actually deserve or what they actually require is basically a violation of the security concept called LUA, or least user access or least user privilege, as it is called in some places. Now, for example, if you are if you're a developer, like going back to our previous example, if this resource group is for project 1, if this resource group is for project 2, and this resource group is for project 3, anyone who only requires access to P1, if they are given access to the entire subscription, then any resource groups that are created, which is, let's say for P4, there is a new resource group which is created, that particular developer who are supposed to have access to P1 now will have access to both P4 and P1 as well. Now the same thing goes to this particular resource group as well. Maybe they have decided that this is for client 2 and this is for client 1. So anything that gets built on this subscription is supposed to be built to client 1, and anything that gets built under this subscription is supposed to be built to client 2. In this case, if a developer who is only supposed to access P3 is given access to the entire subscription on client 2, then that developer will be able to access P2 data and P3 data as well. And